Hey everybody, in this video I want to summarize a bit about hypothesis testing for means. So in chapter 7 we learned about hypothesis testing, and below I've summarized the main steps of hypothesis testing. Keep in mind we're going to be focusing on hypothesis testing with means in this lecture. So you can hypothesis test for proportions or for standard deviations and things like that. And the strategies are going to be very similar. It may have different requirement checks, or you may use a different test statistic, but overall it's the same general process. So if you understand how to test for means, you should be able to read research papers and things like that that talk about testing for other parameters. In statistics, we use hypothesis testing to determine if a claim can be supported or rejected. It's actually a similar idea to writing a thesis paper in an English class in which you're trying to show support for your thesis statement or hypothesis. However, in math, we write using numbers and formulas rather than paragraphs. Most of the time anyway. There is some math where we actually do a lot of writing in paragraphs, but the idea here is to kind of take the idea of writing a paper, but to translate that to mathematics. All right, so there's a couple of things to keep in mind here for testing with means. So first is if the population standard deviation is known, then our distribution is using the normal, or then our test is using the normal or Z distribution. If the population standard deviation is unknown, right, so known versus unknown, then our distribution is the T distribution. So as you're reading through homework questions, you want to be really, really careful to note, do you have sigma or do you not have sigma? Because then you're using different distributions and your answers will be slightly different, so you would get it wrong. So be careful not to mix these up. Then within hypothesis testing, there's been two strategies that we've used to do it. So the first strategy is the p-value method, and the second strategy is the critical value method, or you can also call it the rejection region method, right? So they both start very similarly. Steps like 1 through 4, I would say, are the same. But when it comes time to graphing and then making your conclusion, that's when it gets a little bit different. So again, you want to be really careful not to mix up these steps or like combine them and confuse them with each other. So I think the hardest thing here is that one, or I guess two things, there are a lot of steps to keep track of. And two, there's subtle differences that can be made, right? What distribution you're using, and are you using p-value or critical value method, and your answers or your work, not your answers, but your work can change based on that. So what I want to do, and you can probably fit it here, I'm going to write it on the next, the back side just so I have a little bit more room, is I'm going to kind of summarize and put everything together. So the first thing you would do in all cases, and again, this is for means, is you're going to do your requirement check. So for means, the requirement check is one, is your data random, right? So do you have good data? And then two, it is your sample size has to be at least 30, or your population has to be . The second thing you're going to do, again, no matter what the scenario is you're going to state your claim. And then you're also going to identify the null hypothesis, remember, which has either equals, less than or equal to, a greater than equal to symbol, and your alternative, which is either a not equal to, a greater than, or a less than symbol. So we need to have that set up here. The other thing too is that you can, again, don't forget that your alternative tells you the type of test it is. So if you have a less than sign, we have a left-tailed test. If you have a greater than sign, you have a right-tailed test. And if you have a not equal to sign, then you have a two-tailed test. So again, that is all consistent no matter which strategy or which distribution you're using when we're testing for means. And then the third thing you want to do is you want to make sure that you identify your alpha, right? So what is alpha going to be? And our homework and stuff, it's going to give you alpha. In the real world, you'd be able to choose that as a research team, etc. All right. So I'm going to break it up now into p-value strategy versus critical value strategy. Okay. And then within those two, we actually can break them down again into which distribution you're using. So under p-value, if your sigma is known, then you're going to be using the z distribution. So what happens here is your test statistic is going to be z equals x bar minus mu over sigma over root n. Or if your sigma is unknown, you're going to be using the t distribution. And they look very, very similar for your test statistics because we're still doing means. But your t is going to be your x bar minus mu over s over root n. And actually, it's the same step for critical value as well. So again, it's almost the same process in both cases. It's just a noting, do you have a z or a t here that you're using? So again, over here, if sigma is known, then you're using z. So your test statistic is z equals x bar minus the mean for sigma over root n. Or if your sigma is unknown, then you're using t. All right, so this is I don't know what I like to think of as step 4, basically. And it's really the same in both cases. It's just a matter of do you use z or do you use t, and just be careful that you note that. I'm gonna just draw a line down the middle there to make it a little bit easier. Okay, now in this flow sheet, I can't write every little detail of the tests, obviously, so we have examples for that, but it just kind of to remind you of some key pieces along the way. So once you have your test statistic, again, if you're doing the p-value method, what you want to do next is you do want to find the p-value because remember the p-value is equal to the area or the probability. And you can do it in a few different ways. So again, you can go back to the examples to see it in more detail. But here, if you're using this version, you either use table 4 in the text, or if you're using Excel, just as a reminder, the formula that you're using there, let's make sure I have it written down right, is going to be norm dot dist for distribution. And then what you do is you put in your z from your test statistic, you put in the mean and standard deviation and the word true. And then what happens is this always gives you the area to the left. And the same thing for table 4. Table 4 also gives you the area on the left. So if you do have a right-tailed test, then you could take this area and subtract with 1. Or if you have a two-tailed test, then you could double this area. So you have a little bit of tweaking to do, whether you're using the table or you're using Excel, if you have a right or a two-tailed test. Now for T's, you actually would rather use just Excel here. So there is table 5, but it's not very helpful with p-values. So the Excel formula that you're using here is t.dist. And what you're putting in is your test statistic t. And you're putting in your degrees of freedom. Don't forget that's n-1 here. And then the word true. So that's how you're using Excel in this particular case. And as I was saying with Excel, just like with this one here, you do get that area on the left idea. So you can do a similar thing with the right-tailed and the two-tailed as well. So again, using Excel here, you just want to be careful and recognize that you are typically getting areas on the left and also with table 4. Now, once you have your p-value, what you're going to do next is you're going to compare. If your p-value is less than or equal to alpha, you're going to reject the null hypothesis. And if your p-value is bigger than your alpha, then you're going to fail to reject the null hypothesis. And of course, at the very end, you would want some sort of conclusion or sentence saying, are you supporting the claim, or are you not supporting the claim, or are you rejecting the claim, or are you not rejecting the claim? So you do want that sentence at the end. Now, for critical values, what you're going to do instead after you have your test statistic is you do need to find the critical values. And what happens in this case is your alpha is actually the area of the rejection region. So what happens here is that your alpha is actually equal to the shaded area, whereas your p-value over here was the shaded area. So they do have different interpretations on the shaded part. All right, so in each case, how can you go ahead and do that? All right, so if you have z-scores, how do you find your critical values? You could do one of two things. So you could use table 4. And then in that case, don't forget you're working like inner to outer. So you're working kind of backwards to use the table. Or if you're using Excel, you are using the formula norm inverse. And again, you do give it area to the left, 0 and 1 there. If you have a right tail test in this case, what you would do is do 1 minus alpha to find your area to the left. Or if you have a two-tailed test in this case, you would do alpha over 2 to find your area to the left. So you have a little bit of tweaking there as well. And the same idea of using table 4, right? So if you're using table 4, it's always as area to the left. So if you have shading on the right side or two sides, you're going to have to do a little bit of tweaking there to get the correct value. See, if you're doing your T's, you're going to use table 5 here. And actually, table 5 is really easy to use in this scenario, so I do recommend table 5. But you could use Excel as well. So if you're using Excel, the formula is going to be T dot inverse. You give it the alpha and the degrees of freedom. This works for a left tail test. And if you have a right tail test, what you can do is just make your answer there positive instead. If you have a two-tailed test, there's actually an easier formula to use. It's very similar, but it's T dot inverse dot 2T. Again, you enter your alpha and degrees of freedom, and this is good for a two-tailed test. All right. After you have that, how do you make your decision? Basically, if your test statistic falls in the critical or that shaded region, you reject your null hypothesis. If not, you fail to reject the null hypothesis. So for probability, for p-value, you're looking to see if your probability is small. Is the probability smaller than the alpha? In which case you're rejecting the null. Whereas here it's a more visual check. Is your test statistic in that critical shaded region? And if that's the case, that's when you reject. So you have a probability way to do it, and you have it, again, a more visual way to do it as well. So they're both good strategies, and they're both ones that we have covered in class.